This is example 11.6 from Discovering Design with Chemistry. Recently in the book you've read about the acid-base titrations where an acid and a base are put together and neutralized. We know the concentration of one of them, and so we can use that to determine the concentration of the other one by using the endpoint when the neutralization has occurred and completed. So this problem says 125 milliliters of NaOH solution of unknown concentration is titrated against a 1.29 molarity solution of HCl. It takes 12.11 milliliters of acid to reach the endpoint. What is the concentration of the sodium hydroxide solution? Again, like some of the other problems, we've got two different things, a base and an acid. They're coming together, and so we're having a reaction. So let's first start with making our formula. So we have NaOH plus HCl. We know from previous examples that this is going to produce a water and a salt. So let's make sure everything balances here. They gave us the first two, so we don't have to check on subscripts there. We know water, and then we just have to check on NaCl. That's plus 1 and minus 1, and so that is indeed the chemical formula. And then we can just check and make sure we have the right number of everything. Na, 1 on the left, 1 on the right. O, 1 on the left, 1 on the right. Hydrogen, skip and come back to. Chlorine, 1 on the left, 1 on the right. And then hydrogen, we have 1, 2 on the left, and 2 on the right. So this is balanced. Let's start labeling what we know. The NaOH is 125 milliliters, or in other words, 0.1250 liters. And we know that the HCl is 1.29 molarity. We know that to complete the reaction, we need 12.11 millimeters of acid. And if you didn't recognize that the H here means that this is the acid, they've already given you the number for the other one, so the only one left is the HCl. So we have 12.11 milliliters, or in other words, 0.01211 liters of the HCl. So now that we've collected all of our information, what are we going to do? They want the concentration of the NaOH solution. In other words, we want the molarity of this one. To figure out that, we need to, let's start with our molarity. So molarity is when we have moles over liters. All right, so in the case of this one right here, I'm going to scratch this out so we can focus on the right things. We have a molarity, and we have a liter. So we can find the number of moles that we used. So let's start there. So 1.29 equals moles divided by 0.01211 liters. I probably should have put my units on the other side. Moles per liter. All right, when we multiply both sides by 0.01211 liter, that'll cancel out our unit liters and leave us with just moles. So 1.29 times 0.01211. We get to keep 3 significant digits, so the zeros at the beginning don't count, so that'll be 0.0156. So 0.0156, and that's how many moles we used of the HCl, how much of that was reacted. All right, I'm going to erase this little thing because it kind of looks like it's in the way of the other one. All right, so because we know that, we can imagine a 1 here and a 1 here in front of both of those. So we must have used the same number of moles of NaOH in the thing, which means we used 0.0156 moles over here. And because we know how many moles were used out of the solution, and we know how many liters we used, we can figure out what the molarity is. So I'm going to come over here in this space. I'm going to draw a line though. So this is NaOH that we're talking about. So molarity is moles per liter. So let's fill in what we know. We want to know the molarity, so we're going to leave that blank. Moles is 0.0156. moles, and then we had 0.1250 liters. Like my calculator is always on the side where I don't want it to pop up. Alright, so we have 3 significant digits in the top and 4 in the bottom, so we only get to keep 3, so it's going to round to 0.125. 0.125. We can just put an M for molarity. So that is the concentration of, that's this answer right here that we were looking for. That's the concentration of the NaOH solution. So for this one, we made a formula so that we could relate the different substances involved. We listed underneath each what we had and what we needed, and then we used the formulas that involved those particular things, the moles and the liters and the molarity, to get from one point to another.